Hi everyone. Thanks for the introduction, Timothy. My name is Çetin Yalçın Güleç. I'm working more than 10 years in Softtech. I'm pleased to present our Pulsar experience at commercial consent management system for 80 million citizens in Turkey. And my colleague Shivam Arora participates also in this session. He will share with you our technical challenges and experiences on this project. Our agenda is as follows. Firstly, I will present a short overview about our company, Softtech. Then I will talk about today and tomorrow our use case. And then the last 3 points will be presented by Shivam. Shivam share you our approach and system design, challenges and solutions, and other use cases on Pulsar. We are a global company located in different countries. As you can see, we are in United States, in San Francisco. Subsidiary company name is Maxitech, and also we are a subsidiary company in Germany, Frankfurt, Maxi Digital GmbH, as well as we are in Shanghai, China, Softtech China, and in Turkey we are located 5 cities and North Cyprus. We are developing solutions for different industries, firstly banking and finance, and capital markets, retail, healthcare, insurance, agriculture, logistic, and mobile solutions. We have so many comprehensive products. If to present you in a blocks of our propositions, bottom to up, we have a cloud-ready microservices-based development framework. Name is Plato. And top of the Plato, we have so many developers tools allows the developer to focus on business talks with minimum effort and troubleshooting. And top of this layer, we are build so many products for business and financials industries that are designed to address the specific necessities of next generation digital institution. Top of these products, we have multi-channel management system to deploy capabilities to seamlessly across all kind of channels. We want to mobile first customer journey for our customers. And other side is our proposition is open API perspective. We have open X platform to foster business agility to today's extreme fast and volatile markets conditions. And we have next generation data platform. We work with Shivam in this section, all-in-one and complete solution for managing enterprise data for analytics and machine learning purpose. And our use case. Firstly, we have to create a database which provides management of more than 80 million receivers consents for commercial electronic messages from more than 100,000 companies in Turkey. All companies, its name is service providers. We are naming it service providers. Will register receivers electronics consent is a scalable system. Service provider are responsible to keep a database up to date, and intermediary service providers such as operators have to check the database if receivers has authorized to provide to send commercial information via short messages or email, which require very fast read execution in order not to block LOBs. And intermediate service providers will read the information from the microservices located in their data centers. All the personal information must be stored in encryption. And our consent database is used by 5 different clients. First is service provider. All individual and legal entities sent into commercial electronic message are our service providers. Service providers' responsibility of the service providers is to ensure compliance with legislation. Process must be easy and secure, of course. And the other side of this database using by recipients, it's either consumer or an individual or behalf of a business. Recipients manage all their consents via an account and easily change the status of their consents. They give new consents or close or change existing consents via this system. Another side of this database is intermediary service providers, the firm which is obligated to screen the status of the consent before allowing the message to direct to recipients. And we have solution partners for integration purpose, provide integration service for service providers. And of course, we have to open this database to public authority. There should be a more efficient and effective complaint management system. And our non-functional business requirements are here. First, information will be distributed to 5 data centers. The intermediate service provider want to access the database via microservice in their data centers. The system must be available to encrypt and write at least 1 million records in 60 seconds. And the system must be available to read and decrypt records more than 5 million in 60 seconds. And now I'm giving the floor to Shivam for technical slides.
Thanks, Chetan. Hello, guys. This is Shivam Arora. I'm working as product architect in Softtech. And now I'll walk you through our solution and system design of this project. And then I'll briefly touch upon the challenges we faced in production and their solution. And lastly, I'll talk about the future use cases we are trying to build around Pulsar. So let's start. Here are some high-level requirements for the system. It should be highly consistent, reliable, and the architecture should be scalable. High throughput with a low read latency. Multi-data center deployment. We are currently running in 2 data centers, but in future we might scale up to 4 or 5 data centers. Cloud-first architecture, which is desired from the day one. It's again a future requirement. Room for future business use cases in this architecture. Real-time dashboards to understand the health of the business. And last but not least, use of open source tool as much as possible. This is our architecture in a nutshell. It's a very simplified version of our architecture. We are running our system in a hybrid environment. All our data store layer is running outside of Kubernetes on VMs. As you can see, we have Pulsar as message broker right at the core of our architecture, surrounded by microservices, atomic agents, which are written in Java. Also, we have Keycloak as identity and access manager, and Grafana and Prometheus for monitoring the whole system. At storage layer, we have Elasticsearch. We have used Elasticsearch as a primary data store in this system. We are also using NoSQL Yugabyte DB for replicating data across data centers. So why Pulsar? Well, we have not used Pulsar in production environment before, but we were following Pulsar and its progress for a long time. Thus, we decided to give it a try, and risk we took eventually paid off. So here are a few points we believe helped us adopt Pulsar in this project. Cloud-first approach, deployment charts provided by community and Stream Native are production ready. Most of the use cases can be run with default configuration in production. Pulsar provides both queuing and log semantics, which was very important for us. Selective acknowledgement and redelivery of individual messages. This is also a very important feature required for us. As in microservices, transaction in microservices can time out or fail due to many reasons, be it network issue or congestion at DB layer. Thus, individual acknowledgement of messages was very important for us. Multi-tier architecture, where each layer can be scaled as needed. Segment-centric storage, which allows the storage layer, which is bookkeeper in this case, to scale independently. And smooth cluster expansion and node failure recovery, which we have hands-on in production environment. I'll talk about it in later slides. So this is how we are using Pulsar so far in this system. Currently, a Pulsar cluster is deployed on Kubernetes across multiple data center, which is active. We are using both shared and exclusive subscription. Our system produce and consume JSON payload. All Pulsar metrics and along with other system metrics are being shipped to central Prometheus server. Currently, our production Pulsar cluster is running with the following configuration. We have 3 brokers and Zookeeper nodes and 6 bookie nodes, 285 topics, more than 3,000 producers, and 50,000, more than 50 plus subscriptions. So this is our typical API request flow. Our system handle both sync and async requests asynchronously in the background. We have both public API and atomic Java agent consuming and producing message by leveraging Pulsar. So how do we process sync requests asynchronously, and how Pulsar helped us achieving this? Let's talk about that. When public API pod starts up, they subscribe to their respective topics. Each replica of public API pod creates its own response topic with unique ID name and pass this UID in payload metadata. Similarly, atomic agent pod subscribe to topic at startup as well. We have different topic for sync and async request. Agent subscribe to sync topic with higher priority. So when a request comes from a service provider, let's say a sync request from Open API, it goes to the encrypt topic where encryption agent will prioritize and encrypt this message and pass on to the next topic, which is add consent. From there, the company agent will consume message on priority and write it to Elasticsearch and put success response to specific response topic, where topic name is taken from the payload metadata. Similarly, end user can update their consent status from government portal. Again, the request flow is like send it to encrypt. And this time the encrypt agent process and put message to search consent topic. From there, the search consent agent do a read operation on Elastic and put the response back to topic. Also, we can track history of any transaction in the system. Each agent in the system will write a log of operation performed on message onto action history topic, which is again stored in Elasticsearch. Here are some benefits of using atomic agent in the event-based system. It allows us to focus on business logic. It sets up a producer-consumer for us, thus eliminating the boilerplate code. Each agent can be scaled independently, highly maintainable and testable, dependent on each other, yet run independently. So here are some challenges we faced in production and their respective solution. No message backlog, but topic size was increasing. So after initial production release, we observed topic size was increasing to alarming rate, but there was no message backlog. So we found out that message acknowledgement is a best effort in Pulsar by default. With this, I mean, once consumer acknowledge message, Pulsar performs tasks such as marking message for deletion in async manner, thus, under heavy load, it's possible to see spike in topic storage size. So to avoid this, we increase the JVM size of broker nodes, unload topic manually, and handle message duplication on consumer side. Use negative acknowledgement instead of acknowledgement timeout, which is also recommended in docs. Second one was Kubernetes worker node crash. This one caused a nightmare. Again, in the initial stage of production, we lost all Kubernetes worker node, and total message backlog was around 500 million at that time. So after system came back, one of the bookie did not come up, but we didn't lose any messages. Because of bookie ledger configuration, we had ensemble size of 3, write quorum of 2, and acknowledgement quorum of 2. So here we were able to test the node failure recovery of Pulsar. Third one is instant traffic burst on system causes DB bottleneck. There was a congestion at DB side that was causing backlog size to increase. So to avoid downtime for our API, we stored all async requests on topic by increasing bookie nodes from 3 to 12, each having 1 terabyte of storage. So once DB got stabilized, we processed events and decommissioned extra bookie nodes. So here we were able to test the cluster expansion of Pulsar. Last one is ad hoc requirement for reporting. This is in progress. We were not able to run query for some of the reports on Elasticsearch because it required prior stream processing. So we are planning to store all consent events into topic, and we'll seek message from specific point of time and replay message for ad hoc report requirement as and when needed. Here are some stats from our system. We are currently processing 450 million transactions daily. 6.5 billion consents have been registered so far. We have 115 million unique phone numbers are stored. 180 million unique emails are stored in our system. And we have almost 2 million unique visitors registered from UI so far. This is our current technology stack. As you can see, we are using open source tools such as Pulsar, Minayo, Redis, Elasticsearch, NiFi, Keycloak, and so on. Now, I would like to go through future use cases we are building around Pulsar. First one is an event hub, and this one is for one of the largest bank in Turkey, which has more than 20 million customers. They want to transform most of their monolithic applications to an event-based microservice system. So we are going to build an event hub solution for them. Our solution will again be wrapped around Pulsar. The platform will have a feature like we'll provide them client and REST services for application to connect. Whole system will be run on OpenShift cluster. We use Pulsar function for event routing. So solution will also have cluster management such as topic access control, topic management, deletion of topic, creation of topic, and monitoring of whole system as well. Provide a streaming service for a few of the consumer applications. Replicate mainframe transaction to open system for existing application. So this is a very first use case they want to implement and will be one of the success factor of this project. In this use case, we will use a Kafka on Pulsar plugin provided by Stream Native because IBM CDC can only sync transaction to Kafka as of now. Next one is complex event processing engine around Pulsar. This one is our in-house product in which I am playing a lead architect role. We are finished with an MVP. This is basically a rule engine we have built around Pulsar. Some of the Pulsar feature we are using is event routing and simple data transformation using Pulsar function, delayed messaging for future events, scalability and reliability, of course, multiple subscription type, and message replay using consumer seek. So we would love to share a success story of these two projects later as we make progress. Yeah, that's it from us. Thank you for listening us. I hope you enjoyed the talk. Please ask any question if you have. Thank you.